All right, boys and girls, welcome back to math class. Today, we are going to be talking about functions. I've said this word a couple times so far in our lessons, but today we're actually getting into what is a function, what does that word mean, and I just want all of you to know, as you get so excited for this lesson, just remember, Mr. Sankey puts the fun in function. So let's get into this lesson. So if I were to say, hey, what's a function? You were to say, I don't know. That's fair. Let me pull up some definitions here for you. So a function is a rule that assigns exactly one output to each input. So we're going to have a rule. Functions are rules. And those rules say that for everything we put in, there's exactly one thing to come out of it. Okay, so our inputs, those are our values that we put into the function. Those are our x values. Okay, so another word for function we might see is equation. So the input is the values that are our x's. Our x's in the equation are the input. The output, those are our y's. So the output comes from, we put something into the input, we solve our equation, and that's our answer. Our answer is our output, or our y value. Okay, so we have our function, our input values, our output values, and then even talking a little bit more about this, we talk about something called the domain. And the domain is, what are all the possible values that could go into this function? What numbers could exist as my x values? Because it might not always be all numbers. And then we talk about range. And range is, what are my possible outcomes? What numbers can be the answer to this equation or to this function? So what numbers can go into it and what numbers can come out of it? Okay, so that's going to be where we go when we talk about our functions. Now, let's say, taking that information, let's say that we know somebody and her name is Gina. Okay, so Gina has a phone. Her parents are like, hey, I don't want to pay for your phone anymore. You now have to pay for your phone. And good luck, because phones are dumbly expensive. And so Gina's trying to figure out how much money it costs for her to own her phone. She's trying to say, all right, how much money does it cost to own her phone? And she wants to know she wants to track it over a long period of time, over a whole year. Every month for a whole year, she wants to track how much money does her phone cost. And she can do this by creating a function. And in this function of the cost of a phone, per month, Gina wants to know, what is the domain I'm looking for here? The cost of a phone per month. So remember, when we talk about domain is, what are all the x values that could exist? What are all the numbers I could input into my equation? And so for Gina, her domain is going to be all the numbers 0 through 12. Because she wants to track it for a whole year. There's 12 months in a year. And she has to start with 0, the 0th month, before she's paid anything. She can't go into negative months. Negative months don't exist. So she's going to start at 0 and say, how much money am I spending from 0 months to 12 months. Let's see, when she wants to track it over her lifetime, she'll say 0 to infinity. And it can just go forever and ever in the direction of every single month for her whole life. That was my grandpa. He was like so meticulous in all of his planning and tracking and spending and budgeting and all that stuff, as he like wrote down every purchase every day, everything he spent money on, kept a whole track of it in books on books on books, and it's so much work. I don't know why he did it. That is not the way that I do things. Some people do. Good for them. It's not for me. All right, so let's say that in this phone situation, okay, let's say in this phone situation that Gina wanted to keep track of how many phone calls she made a month. She was only allowed to make 50 phone calls a month, and so she wanted to keep track of how many phone calls did she make a month. And so here is a month and calls. And in month 1, month 2, month 3, month 4, month 5, and month 6. Month 1, Gina made 41 calls. She wanted to call over friends and say, hey, I got this new phone. Month 2, she made 26 calls because she realized making calls is not as fun as sending a message. Month 3, 32 calls. Month 4, 35 calls. Month 6, 37 calls. And month 5, 37. Month 6, 43. So that is how many calls that Gina made in her month. So here we'll have our month, and this is our X values. Here we have our calls, that's our Y values. Now, if I were to ask you, is this a function? What would we say? Well, we'd look and we'd say, okay, well, every input has its own output, right? Every input that exists has its own unique output, right? Month 1 has a number, month 2 has a number, month 3 has a number, month 4 has a number, month 5 has a number, month 6 has a number. There are no repeating inputs. Because there are no repeating inputs, this is a function. Because all of our inputs work like that, it is a function. Now, what if I were to take month 5 and say month 5, she accidentally pocket dialed somebody twice and it really was only 35 calls. Now, would this be a function? So if you look, month 4 and month 5 both have 35 calls. Does that make a difference to say, is this a function? This is a function. I don't care about the outputs. All of those numbers could be 35. All those numbers could be 0. I don't care. I don't care about the output values when we determine if something is a function. That doesn't matter for us. So this is still a function. Now, let's say that up here on month 2, this accidentally was written as month 1. Now, would this be a function? If I have 2 month 1s here, would this be a function? This is not a function. I cannot have the same X values in my function. Every X value I have, every input I have needs to be unique in order for this to be a function. So we can tell, looking at a table, we can tell, do I have the same input value? If I do, it's not a function. Another way we can look is to say, okay, looking at another type of thing. This is called a mapping diagram. And this mapping diagram is like 2 kind of like oval things. And it'll say 1, 2, 3. Here's my X. Here's my Y. Over here we'll have 10, -2, -14. And then we have lines that say, here's a point, here's a point, here's a point. And so it's going to say when X is 1, Y is -2. When X is 2, Y is 10. When X is 3, Y is -14. And that would be the function that we're using. And this would be a function. Because each X value is only being used once. If I were to come through and say 1 equals -2 and 1 equals 10, this is no longer a function because 1 equals 2 different things. Every input has to have only one output. My outputs can be the same. I could have had all of these right here, say, all of these values equal 10. That's fine. I don't care about my y's. I only care about my x's and that they're all unique and single. Okay? I want my x's to be single, don't care about my y's. All right. Let me get rid of all of this. I don't know why I didn't just move it all away. All right, let's say I had a graph that looked like this. This was the graph that I wanted to look at, and I just wanted to say, okay, what is the domain and range of this graph? Remember, domain is my x's, range is my y's. So I said, so looking at my x's, I want to know where do my x's start and where do my x's end. I would say my domain is 1, x is greater than 1, and x is less than 10. I'll say x falls in between 1 and 10. I'll do the same thing for my range. I would say for my range, I want to look at my y's to my y's. My lowest y is -2 y, and then my highest y is going to be 7. So my range is from -2 to 7. My domain is from 1 to 10. What would my domain and range of this graph be? So if I were to do my domain and my range, what would my domain and range of this graph be? Let me know. All right, we will continue to talk more about functions tomorrow, but for now, have a great rest of your night.